It's Roger once again, Mud Fossil University, today talking about the Higgs boson and the monopole, which I believe are totally related. Now, I claim that Rod Warren and I, during light experiments, have actually created the Higgs boson and seen monopoles and seen their interaction with the actual ether of space and which surrounds everything. And I will show you that right now and explain to you why I make these claims and statements. And then I will go on to show that matter is literally the most simple form of particle interactions that you could possibly imagine. There is only two things. There are protons, which are large positive masses, and then there are the tiny electrons. That's it, no neutrons. The protons become flooded with electrons in their nucleus until they can no longer accept them. That's it. They become neutralized in the nucleus. And then more will try to invade the nucleus, creating a negative zone around the nucleus, which creates orbitals. And as the orbitals line up trying to get to the positives, protons of the nucleus, they stack up in orbital formation in an exact quantum distance because it is so defined by these particle sizes, and there is only massive protons, and then there is negative electrons, and they flood that massive proton until it takes on just the tiniest excess negativity. So you have a massive positive and a tiny excessive negative by flooding it by these particles. That's all it is. Okay, it can't get any simpler than this. Now, I did make some mistakes in original, so some of this I'm going to have to explain in a second. But this is the basic structure of an atom. Well, there's no neutrons, absolutely zero neutrons. These are the protons, and they are 1,800 times larger than an electron. 1,800 times. So there would be 1,800 electrons for every one of these. So you got a ton of electrons because they're going to try to hit up against the positives. They are negative going for positives. There's no neutrons rolling around on the floor. They are always, 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 always attached to a proton. And a proton always has exactly one neutron attached to it until you start building up high amounts of neutrons in a nucleus. And then you get a whole bunch of extra negatives because, and it becomes what they call oxides. And it's just a function of them trying to fill up and attach to the positives. It's just as simple as that. So there's going to be a zillion little negatives, and then eventually it's instantaneous, but they attack the positives because the whole Earth and the sky and the universe is flooded with negatives. That's the ether. That's the ether. So there's always negatives waiting to try to find positives. There's always negatives waiting around. So as long as you create a place for a negative to go, it's going to go. So, but you have to have a positive once to take it in, and most of the positives are already flooded with negatives. So most things are neutral. It's just the way it works. It's like forcing it, and it's done. They all have their own electrons satisfying what they want, so they become virtually neutral. However, this is the key. So anyway, let's talk about the core. Now we have a core that's highly positive, but it's also highly negative. It's equal with an excess negativeness because they're still trying to get in here. That makes them stack up in orbitals around here, all saying, "Hey, if you guys would leave, I'm coming in." And they said, "No, we're staying here. I like this guy," and they stay there. Eventually you get bombarded to crush this space in somehow, like an atomic bomb, boom, 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 or light coming in and smashing, bumping one of these, it bounces down and flies off because it got hit with such an impact. And as it does it, it shakes, and that becomes heated, and that's heat and vibration. The impact bouncing one of these out is light. That's all it is. It's as simple as that. And the faster they come in, the more damage they do. The more spin they have, which from the monopole, the spinner that is, the hammerer it hits. So it comes through like a zim, zim, zim. It bumps into that, no big deal. It comes through, zzz, bam. Case closed. Now, I did this a while back, a diagram, and this is not right now, but it's pretty damn close. Now, you have a proton, and that weight is 1.672. Now, they called it, I was calling it a negatron. It's not. It's just an accumulation of electrons until it exceeds the proton by a zillionth. 0.0002 or whatever it is, a 0.002. There's 1,800 electrons for every proton. So the negative, forget that. That's also now a mistake. They're just negatives. And they have so many accumulated on top of that proton because it wants every one that it can take until it becomes comfortably neutral. Now, and then I was showing that the net is a negative net charge, which there will be a negative net charge on the nucleus because there's more of them going to try to get in than can. And then they will quantize around the distance in the layers of electrons. Here it is. The excess weight, which is the charge of the negatron, which is now just a flood of electrons, creates a quantum distance that the electron cannot penetrate. Simple as that. As the layers of electrons collect, they create the shells, each repelling the next. The end. Case closed. Now let's go do a little more looking. I just realized what I said. I said oxides before. Oxides are clearly not correct. That's oxygen compounds. These are isotopes. Now, an isotope means that you have, normally, let's say you have 6 protons, and then they say 6 neutrons, but let's just work with protons, because everything else is electrons. So, if you had 6 protons in this core here, you would have 6 electrons out here. Okay? Now, that means that this thing in here has 6 times 1,800 electrons in this core, making up the nucleus, and then there's 6 additional ones surrounding it. That's copper. I'm sorry. I'm telling you, I'm losing it, man. That is carbon. Okay? 6 and 6. All right? Now, that's carbon-12. All right, now everybody's heard of carbon-14. Carbon-14 means that there's 2 additional electrons in this nucleus. All right? And that's what they call an isotope. So, and then there's also carbon-13. Carbon-14, the one of these little buggers in here tries to get out of here. And then it drops down to carbon-13, carbon-12, and that's what the C14, carbon-14 dating is all about. And that does not work because carbon moves through everything. It's carboxylation, it's called, and it moves with transition metals throughout everything forever. It never stops moving, and that's why rocks transition and end up coming down to like quartz and things like that. They don't just do that instantaneously. All of a sudden it turns into quartz in a day. No, it continues to transition. What transitions? Everything that's in there that contains metal compounds which are working with carbon. So carbon comes in and out. I can't see how it could possibly work. All these dates are very, 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 very off. I'm going to tell you that right now. So that's just another thing. All right, so what is a monopole? A monopole has only a north or a south pole. That's it. There is no, like a bar magnet has one on each end. No, this is strictly a chunk of negative or a chunk of positive. Now, they had not been able to find these, and this only goes back a couple of years. They couldn't find them. It says the existence of even a single Dirac magnetic monopole would have far-reaching physical consequences, most famously explaining the quantization of the electric charge, and it has, and I have photographed it, and I have evidence of it. You can go and read up about magnetic monopoles, but basically anytime you take a magnet and break it in half, you get 2 more bar magnets just half as strong. That is not the case with monopoles. It breaks and you have a continuous north and a continuous south. That's what we're dealing with now. Okay, the Higgs boson is the particle that creates a field. It's a it's a boson particle, which if you can see these tiny little white streaks, I'm saying these are the particle trail. The head of it is the the Higgs field. So you have the Higgs field on a boson particle. So as that particle, which is a charged particle now, this is a monopole, a negative particle, spinning through space, fast, creating anything around it to be affected by that negativeness passing by it fast, just as the way electricity does, exactly identical. So whatever is around it, surrounding it, that can be polarized, becomes polarized. If it was magnetic filings, you would see the magnetic filings show up around here. If it was ether, which ether is nothing more than the moisture in the air collecting an extra electron attached to it. And that creates a bar magnet effect in midair, and I will show you the ether, and that is what creates the polarization that can do this dot 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 dot, creating the field around the particle as it passes through space. And these are, how did we achieve this? To be able to see it, you normally don't see these, because we accelerated the light through a Venturi, and that is the actual slowing down of the light after it exits the Venturi, and it becomes visible with the little coaxing. Rod Warren did the light experiments here with this, and outstanding work to get the visual effect. Absolutely phenomenal. I'm going to show you a few other ones. Now, you see this? I talked about polarized particles in the air. This is it's moisture in the air that has an extra electron attached to it. H2O is an extremely polar molecule, extremely polar, has a high centers of positive and negativity, and so it's basically a magnetic, and that's why it has that surface tension. It holds together like a skin. It all wants to attract to each other. It wants to find another negative and positive. Well, in the ether of the air, it only finds negatives. So what happens is they show up as polarized particles. That's all that is. Now, this is a pulsed red laser coming through the air. That's all it is, a nice little happy wave coming through the air, and that's how it would go forever, except we put it through the ringer. All right, you remember I showed you those other magnetic fields, the little circles with the dots in them? Look at this. Look at how extreme this reverse magnetic field is from this interaction. This was that happy little wave coming along, just going along nicely, and all of a sudden it became sucked into a Venturi slit, which is two cylindrical shaped metal shafts that forced the particle, or the stream of particles, to interact with each other in such a nature as that they create chaos, and they atomize, really. And a light is nothing more than liquid. It's a liquid. And it becomes atomized, and Rod said he could actually hear it sizzle every now and then when he was doing these experiments. Now, the interaction of the magnetic field here, instead of coming forward, just happy little wave, it's exploded backwards in this enormous amount of Higgs boson action, really, is what it is. So that should be investigated. I mean, what the hell is all that stuff out there? That is a huge interaction, and we can see that it's excited itself extremely. And I can show you the chaos shots and a couple other things, just so you get the full understanding. This is what's happening. Coming through here, it's like this. It's not coming through like this. It's coming through in a spin like this, and it is a right-hand spin, because that's the nature of electricity, and it's shown in our light experiments. And as it exits through the slot, if it spins this way, it'll go off to that way. If it comes over the top and it's spinning this way, I mean, it's spinning the same direction, but if it's over the top, it goes this way. If it's under the bottom, it goes that way. That's all. And most of them hit sort of the center, and that's why you get the big blob in the center. Very, very easily understood. All right, this is looking straight down at the accelerator, and it comes out in all kind of chaos, and then it steps down and it starts to reform into the spinning monopoles, because they're monopoles. They don't want to touch each other. They want to stay away from each other. However, there is an extremely interesting interaction that I'm going to show you in a second. Okay, remember this one now. That's coming out of the accelerator directly at us. Zoom, right into our faces. Now, that's an extremely excited particle that has come through the accelerator at a higher speed than the other ones. So the speed is the color. That's all I can tell you. The speed has to be the color, because it is coming at a much faster speed than the others. And the reason I can say it's at a faster speed is because of the interaction it has in a second. But don't forget now, these are all negative particles. They do not want to be in each other's regions. You see how they're all just very elegantly separated. Very interesting that they're not all colliding. Although after the chaotic slit part a minute ago, you could see they did interact a little here and there, and that's what this one's going to do. And I'm going to show you that interaction, which tells me that these particles are not a standard size. These particles can be reduced, and I'm going to show you the evidence I have for that. All right, I've shown this a lot. This is that white particle. It's coming at an accelerated pace, and the reason I say it's accelerated because it is a white congealed mass that interacted with this field. So it has a field apparently, because you can see it stepped down into its own field, which will become very similar to this, is my expectation, because you can see it beginning to form, and this is tapped off of it. So now we know that there is a electronette. I don't know, I call them light trumpets. They every now and then they'll tip off a little tiny piece of a field, which to me is a piece of a particle. If this is a particle creating this field, and there's a particle creating this field, and there's a particle creating this field, then this is a particle creating this field, which came from that particle, which means it can be divided. That's all I can say. I'm seeing it come faster, obviously, because it collided with this. They do not want to touch each other. They are the same polarities. They do not interact with each other. And that is why in space, coming from the sun, which these are nothing more than electrons, excited so much that they achieve escape velocity from the sun, they spin off into space in all different directions. The ones that hit us on Earth become visible on Earth because they bounce against other clouds of electrons that are bouncing off of the positive mass of their nucleus. So there is no positive masses of nucleus in space, so they all stay away from each other. They are still matter, and they are still energy. They're dark energy and dark matter in space. It's all it is. Obviously it left the sun as a particle, and obviously it hits us as a particle, and obviously in space it's a particle. It's as simple as that. You got to get away from Einstein. This is what destroyed everything. Because if you speak the way I speak, and you are in the field of science, and you are trying to come home with a paycheck every week, you will not. You'll be end up living under a bridge. They will destroy you for talking against Einstein, and that has destroyed science for 100 years. Okay, you've seen what I have to offer. Now, the only thing I can say is you have to step away from Einstein. Forget about neutrons, forget about all of the stuff you learned about this, and look at it from the perspective I offer it from. Every single interaction from heat and light and sound and electricity and sonoluminescence and every single interaction, static and gravity and anti-gravity and nuclear explosions, 100% perfect. I can find no flaws whatsoever. If neutrons go away, the speed of light can be who knows what. Particles are tiny, That's all I can say. You see what I see, and I think it's time to investigate it in this manner rather than making up all these silly, spooky, entangled, dark this and that from a distance. It's just that's what the problem is, because you make up they take pages and pages and pages and to explain something you can't explain. So by the time you get to the end, you're so confused and so frustrated. Oh yeah, that makes a lot of sense. You just want to get out of there. All right, I'm showing you. Somebody tell me where I went wrong. That's what I want to know. Where did I go wrong? All right, I've shown the evidence. Show me your evidence. CERN just wasted a whole lot of money. That's all I'm telling you. So if you want to stay in the dark and just hope you can figure out something that is just fantasy land and make it work, which it never does. That's why it's always, oh, scientists were so amazed. They were so baffled, I mean, it just goes out. You never hear them say, yep, exactly what they expected. I don't think I've ever heard that, to be perfectly honest with you. But this experiments I'm doing, every time that I came up to a point where I said, oh boy, I hope this thing works, it was there. It's just exactly what I expected to see. And in such magnificent detail. It was amazing. So you take it for what it's worth. But I'm amazed that not one single university or educator or teacher or professor or anyone has taken any notice of this. And it's been distributed out widely and no one's had any interest whatsoever. Which is the case with all things, and that's why education is such a disaster, because they want to hide and put it in the lab somewhere and figure every little detail in years until they come up with something. I just put it out there. If I'm wrong, I'm wrong. If I'm wrong, I'm wrong. So what? I can adjust it. I can figure out later. I was wrong about the negatrons. I was wrong about a lot of stuff. I mean, I get wrong every day about something, I'm sure. Because sooner or later, I figure it out, though. I don't just drop it on the floor and, oh, that's it, I'm done. Or I don't want to look at that because it doesn't make sense to me. Anyway, there's a little more of my frustration. I just can't help myself. I just can't imagine how anybody could even get educated in this country anymore. I am in the US of A, but it's in England. It's all over the Western world. Russia in that area, I mean, I'm impressed with their ability to have open-mindedness. I really am. And we need it here.